The third type of equation that we're going to be dealing with are equations that have multiple angles. And what I mean by that is I'm going to increase the frequency of my function. So for example, we know y equals sine of x. If I go from the interval 0 to 2 pi, I'm going to cross the x-axis at 0, pi, and 2 pi. But what happens if I increase the frequency? I'm going to increase the period or decrease the period of a specific trig function. What happens to the number of solutions? Well, here we can look at y equals sine of 2x. And if I do that, from 0 to 2 pi, I know this is not drawn to scale at all, but from 0 to 2 pi, I'm now going to have twice as many solutions. Here from 0 to 2 pi, technically these two are the same solution, 0 and 2 pi. So let me ignore that one. I've got two solutions. Here, 1, 2, 3, 4 solutions I'm going to have. Once again, I'm going to ignore that 2 pi because that's identical to that. So when I have 2 in front of the x, I double the number of solutions. If I were to follow the same thought process with sine of 4x, 1, 2, 3, 4, I'm going to have 4 times as many solutions. So with regards to the original function, how do the number of solutions change as you add constants in front of the variables inside the trig function? If you have a number that's going to be greater than 1, you're going to increase the solutions. And then if it's between 0 and 1, you're going to decrease the solutions. And these are both on a set interval. Specifically the set interval of 0 to 2 pi. Because we know this goes on forever, infinitely in both directions. So technically there's an infinite number of solutions. But if we're going to restrict ourselves from 0 to 2 pi, there's a direct relationship where if we have a 2 in front of the x, we're going to have 2 times as many solutions. If there's a 3 in front of the x, we're going to have 3 times as many solutions. If there is a 1/4 in front of the x, we're going to have 1/4 the number of solutions from 0 to 2 pi. So we want to deal with equations that are considered multiple angle equations. And what that's specifically saying is we've got a constant that is in front of the variable, whether that's theta or whether that's x. So right here, 2 sine of 2 theta plus 1 is equal to 0. I want to find all solutions in pi radians. So I'm going to solve for theta. We've got the exact same process as before, but the only thing that's different now is we've got this extra 2 in front of the theta that we've got to worry about. So if I were to solve this the exact same way I did before, I'd first subtract 1 from both sides. So 2 sine of 2 theta is equal to negative 1. Divide both sides by 2. Sine of 2 theta is equal to negative 1/2. And now the step that we always like to write down is the inverse step, or the arcsine step. We are going to take sine inverse to both sides. So that my sine and sine inverse cancel out. And so I'm left with 2 theta is equal to the sine inverse of negative 1/2. Now right here is probably the most important part of the lesson, in that I cannot divide through by 2 yet. I first want to solve over here, and then I'll divide everything by 2. So I want to know sine inverse of negative 1/2. What two angles are going to produce a sine that's a negative 1/2? Well, we know sine is negative in the third and the fourth quadrant. So I'm looking in the third and fourth quadrant on my unit circle for angles that have values of a negative 1/2. So let me pull out my unit circle just in case you don't remember. There's my unit circle. Sines are the y values. So right here is a negative 1/2 for the y in the third quadrant. Here we've got a sine, or a y value of negative 1/2. So the two angles I'm looking at are 7 pi over 6 and 11 pi over 6. So sine inverse of negative 1/2 is going to be 7 pi over 6 and 11 pi over 6. So really, this is 2 theta is equal to 7 pi over 6 and 11 pi over 6. Now, I can't just divide by 2 and say I'm done, because I want to have all solutions in pi radians. So what I've got to do is I've got to write this answer in my final format and then divide by 2. So really, what this is going to be is 2 theta is equal to 7 pi over 6 plus 2 pi n. Remember, all solutions, that plus 2 pi n tells me every single time around the unit circle. And then 2 theta is equal to 11 pi over 6 plus 2 pi n. Once I have that written in my format that I've done before, now I can finalize my answer by dividing every single piece by 2. And if I divide every single piece by 2 here, divide this whole thing by 2 or multiply by 1/2, I'll get 7 pi over 12 plus pi n. And then my other one here, if I divide this piece by 2 and this piece by 2, or if I multiply this piece by 1/2, which is the same thing as dividing by 2, I'll get 11 pi over 12 plus pi n. So there's my solution that represents all solutions in pi radians. Big thing here is you're going to solve this equation just as you have before. Every single step is the same, with the exception of the very final step, which is when you divide through by your constant or multiply through by a constant. Do not do it up here. You need to do it once you've got your plus 2 pi n in, so that you can affect that 2 pi n to be, in this case, a pi n. The second example, the cotangent of x over 2 is equal to -1. That's what we get when we move our 1 to the other side. So cotangent of x over 2 is equal to -1. This x over 2 is really the same thing as me saying 1/2 x. So I can rewrite it with the 1/2 in front just to make my notation a little nicer. And now in order for me to get that 1/2 x by itself, I'm going to take the cotangent inverse to both sides. So cotangent inverse of -1. So 1/2 x is equal to the cotangent inverse of -1. Now, we know that we don't have a cotangent inverse button on our calculator, so I've got to rewrite this in terms of something that I do have a button on the calculator for, which is going to be tangent. So really, cotangent we know is going to be -1 over 1. That means I can rewrite this as the tangent inverse of 1 over -1. I'm just going to flip my numerator and denominator. So in this case, the cotangent inverse and tangent inverse are both going to be the same. They're both going to be -1. So tangent inverse of -1. So I'm going to go back to my unit circle. And I want to know, where is tangent have a value of -1? What are those two angles? Well, we know tangent is going to be negative in the second and the fourth quadrant. So I'm going to go to my second and my fourth quadrant. So I look at my second quadrant, and right here is -1. So I'm going to have 3 pi over 4 as one answer. And then my tangent is also negative in the fourth quadrant right here, which is going to be 7 pi over 4. So this tangent inverse of -1, 1/2 x, is going to be equal to 3 pi over 4 plus 2 pi n. And it's going to be equal to 7 pi over 4 plus 2 pi n. But I'm not done yet. I need to get x by itself. So since I've got a 1/2 over here, I'm going to multiply both sides by 2, which means if I multiply this piece by 2, I'll get 6 pi over 4. Multiply this piece by 2, 4 pi n. And here, if I multiply this side by 2, I'll have 14 pi over 4 plus 4 pi n, which then simplifies to 3 pi over 2 plus 4 pi n. And then 7 pi over 4 simplifies down to 7 pi over 2 plus 4 pi n.